Hello and welcome to today's class. We are going on with differentiation, and in today's class, particularly, we are going to tackle equations of tangents and normals to curves, basically by use of differentiation. All right, so I hope we all know what a tangent to a curve is. Basically, a tangent to a curve is a line that forms a perpendicular line with the curve. Okay, so a tangent is a straight line that is perpendicular to a curve. All right, so that is what a tangent is. All right, anytime you have a straight line that is perpendicular to any point of a curve, then we say that that line is a tangent to that curve at that particular point of intersection. Okay, all right, so that is what a tangent is. All right, any line that is perpendicular to a point in a curve. All right, and so usually one thing I want us to note here is that uh, the gradient of the tangent is usually the gradient of the curve at that particular point of intersection. Okay, so I'll note it down here that the gradient of the curve, the gradient of the tangent, is the gradient of the tangent is also the same as is equal to the gradient of the curve at the point of intersection. So maybe if I just clarify what this means. So let's say that we are having a curve here. I'm going to give it a random equation. So that's going to be y-ax squared plus bx plus c. All right. So let's say we have a curve there, and that we have a tangent here. So this is a line. Let's have this line cutting across this point here. All right. And we call this line. Okay, we give the equation of this line as y equals to ax, all right, plus c, all right. So it's the equation of a straight line basically. So the gradient of this line, straight line here, basically no, just a minute. Sorry, let me not go ahead of myself. So this line here is what we're calling a tangent. That's a tangent. This should have been n. This line is what we're calling a tangent. All right, this line that actually forms a 90-degree angle with this curve at a point at the point of intersection is what we're calling the tangent. That's the first thing I want you to note. Okay, so this straight line that has actually intersected the curve at this point at an angle of 90 degrees is what we're calling a tangent. All right, and also we are saying that the gradient of this tangent, all right, the gradient of this tangent, that is change in y over change in x, all right, of the tangent is equal to the gradient of the curve at the point of intersection. Okay, is equal to the gradient of the curve at the point of intersection. All right, so basically, for us to determine the gradient of this tangent, we basically have to just find the gradient of the curve at the point of intersection. All right, so that is the statement that I want you to come out with from our understanding of what a tangent is. All right, now normal to a curve usually is but the perpendicular line at the point of intersection between the gradient and the curve. So if we may have, let's say, another line, I think this would have been properly illustrated with with, let's say, a different ink color. So let's say we have another line. I'm going to draw another line. Let's say a line. Okay, so this line basically is intersecting with the curve and the tangent. Okay, so this line is intersecting with the curve and the tangent. So if I have a line, and I'm trying to sketch it out here, right? If I have a line, I hope it's visible. If I have a line that I'm drawing here, and I'm going to name this line y equals to bx plus c, all right, bx plus c. So if I have a line that is also forming a perpendicular with the tangent, if I have a line that is forming a perpendicular with the tangent, all right, a line that is forming a perpendicular with the tangent, then we say that that line is normal to the curve. All right, we say that that line is normal to the curve. So a normal line to the curve, when a line is said to be normal to a curve, it is basically a line that is perpendicular to the tangent of a curve. Okay, so that is what we call a normal line. So a normal line is basically a line that is perpendicular to the tangent of a curve, as I've tried to illustrate in this particular diagram. Now, why don't I give a final statement? Then maybe I perform an example out of all this. So let me make this statement and say that when we study gradient, we realize that when lines are perpendicular to each other, all right, when lines are perpendicular to each other, then the product of their gradient is usually equal to negative of its reciprocal. And that one we're going to negative of its reciprocal. And that one we're going to basically we're going to look at. Let me not go ahead of myself. Let me not go ahead of myself. Let's just tackle an example first. Let's just tackle an example. Yes. So we are told to find the equation of the tangent to the curve, y equals to x cubed plus 2x plus 1 at a point 1, 4. All right, so I'm going to basically remind you that a tangent of a line to a curve basically is a line that forms a perpendicular with the curve at a point, right? With the curve at a point, and that the gradient of that curve, at that point of intersection is usually the same as the gradient of the tangent. All right. So basically, for us to solve this problem, because we are told to find the equation of the tangent, we are going to first of all try to find the gradient at the point 1, 4, as that is the point of intersection. And remember that the gradient at the point 1, 4 is also going to be the gradient of the tangent of this line that we are trying to figure out here. So the first step is going to try and find that gradient. And so for us to find the gradient, we are first of all going to differentiate our function y equals to x cubed plus 2x plus 1. All right, because when we differentiate this function here, which is the function describing the curve that this problem is asking us to find the tangent of the line to, we are going to then find what we call the gradient function. Okay, all right, so by differentiating the function y, we are going to find the gradient function. Okay, and that happens for any function, that anytime you differentiate a function of a curve, you will always find its gradient function that you can always use to find the gradient of that curve at any given point. All right, as gradient of a curve is instantaneous. All right, so for us to find the gradient function, basically we're going to differentiate dy with respect to x. And so this is going to be 3 times 1, that is 3, x, 3 minus 1, that is 2, plus 1 times 2 is going to give us 2. All right, 1 minus 1 giving us giving us x raised to 0, which is just 1. And so, of course, we all know right now that the gradient, the derivative of any constant is always going to be equal to 0. So the derivative of 1 there is going to be equal to 0. And so our gradient function in this particular case is 3x squared plus 2. All right, so this is our gradient function of the curve y equals to 3, y equals to x raised to 3, plus 2x plus 1. And so for us to find the gradient at point 1, 4, we are basically going to substitute for the value of x, which is 1 in the gradient function. So gradient so the change in y all over change in x at 1, 4 will be 3 into 1, okay, taking the value of x in this coordinate. So 3 into 1, x, substituting directly into the gradient function, okay, plus 2. And note that this is going to give us 5. So this here is the gradient. This 5 this here is the gradient at, okay, so this is the gradient at the point 1, 4. All right, so this gradient also happens to be the gradient of the tangent. All right, the gradient at that point of intersection, remember, also happens to be the gradient of the tangent. So basically what you're going to do in order to find the equation of the tangent to the curve at the point 1, 4, we are going to then use this gradient, which we found to be 5, and this coordinate to find the equation of a straight line. So this is generally unrelated to differentiation. It's under a new, and it's under a different topic altogether called gradient and straight lines, a gradient of straight lines. So basically, if you haven't, if you don't have proper understanding of this, I'll be dropping a video on gradient of straight lines, so it will be easy to relate to this afterwards. So basically, I'm going to have the gradient of the tangent, the equation of the tangent, at 1, 4 will basically be y minus 4 all over x minus 1 equals to the gradient, equals to 5. And so when you cross multiply, all right, on both ends, you're going to get y minus 4 being equal to 5 into x minus 1. All right, and so this basically will give us y minus 4 into 5x, all right, expansion minus 5, all right, into 5, okay, minus 5 right there. Okay, so we make y the subject of the formula, and so when you make y the subject of the formula, we're basically going to have the y equals to 5x minus 5 plus 4, which simplifies to 5x minus 1. And so the equation of the tangent to the curve at the point 1, 4 will be given by this equation here, that is y equals to 5x minus 4. So the main thing that I want to take away from this particular class today is the fact that we found the gradient function using differentiation. Okay, so this here was the gradient function. All right, the fact that we found the gradient function using differentiation. So that's the main takeaway I wanted to take away from here. And also that whenever you are talking of a tangent to a curve, then it has the same gradient as the point of intersection at that particular curve. All right, so then it becomes easy to form the equation of the tangent. All right, so why don't we perform the last example where we try to find a normal to a curve, and then we call it a day. All right, so here goes the last example of our class today. So we are supposed to find the equation of the normal to the curve. All right, so we're supposed to find the equation of the normal to the curve. That is y equals to x cubed minus 2x minus 1 at the point 1, 2, at the point 1, negative 2, sorry. All right. So for us to even, before we can even go ahead and solve this, I want to remind you that I told you that normal to a curve, all right, when you talk of normal, a normal line, a line that is said to be normal to a curve, then it is a line that forms an intersection with the tangent. All right. So what do we know about and it's a line that forms an intersection with the tangent, and that the angle between those two, but the angle between the intersection is actually 90 degrees. So basically, a normal to a curve and the tangent line are perpendicular to each other. And what we know about perpendicular lines is that the product of their gradients, okay? Whenever lines are perpendicular, the product of their gradients is always equal to -1. So as a side note, I'm going to have it here, that the product of the tangent, all right, the product of the gradient of the tangent and the gradient of normal to a curve will always be equal to -1, and that is because they are perpendicular. All right, that's because they are perpendicular to each other. So basically, for us to solve this problem, we are supposed to first of all find the gradient. All right, we're supposed to first of all find the gradient of the tangent, and then we will use it to find the gradient of the normal to the curve. All right. Of course, because we know that when you multiply the gradient of the tangent and that of the normal, we should always get -1. So we are having the equation of the curve as x cubed minus 2x minus 1. And the point of intersection of the tangent and the normal, all right, is the normal and the curve as well, is actually 1 and -2. That's okay. So what we're going to do is first of all find the gradient function using differentiation. And so we're going to differentiate the function y with respect to x. All right. And note that this is going to be 3 times 1, which is the coefficient of x here. And that will give us 3. All right. And then we'll have x3 minus 1 giving us 2 there. Okay. Minus 1 times 2 giving us 2. And of course, 1 minus 1 giving us x raised to 0, which is basically 1. And so we just, any number raised to 0 is usually equal to 1. So that is basically 2 times 1 is just 2 anyway. And of course, we also remember that the derivative of the derived, we should also remember that whenever we're deriving constants, their derivatives will always be equal to 0, right? So so in this particular case, -1 will just be equal to 0 when we try to differentiate it. All right, anytime we differentiate constants, their derivatives will always be equal to 0. So this here is the gradient function. So with this here, we can actually find the gradient of the curve at the point 1, -2. All right. So with this here, we can find the gradient of the curve at the point 1, -2. And we also have to note that the gradient at that point of intersection is also the same as the gradient of the tangent. All right. All right. So by finding the gradient at point 1, -2, we've also found the gradient of the tangent. All right. So basically, you're going to have that the gradient that is change in y over change in x of the tangent at 1 negative, at that point of intersection, will be equal to 3, all right, into x. The x coordinate is 1 there, 3 into x squared using the gradient function minus 2, all right. So that is going to be what? That is going to be 3 times 1, all right, 3 times 1, which is 3, minus 2, basically 1, all right. So basically, The gradient of the tangent in this particular case we are finding to be equal to 1. So this is the gradient of the tangent. All right. But remember, we are supposed to find the equation of the normal to the curve. And now, because we have the gradient of the tangent, we can find the gradient of the normal. Awesome. So we have the gradient of the tangent at the point of intersection, that is 1 and -2, to be equal to 1. And so remember the relationship between the tangent and the normal to a curve, all right? So we say that the gradient of the tangent and the normal of the curve, when you take their products, you should always get what? -1. So now we have the gradient of the tangent here. So to find the gradient of the normal of the tangent, basically we are going to have a situation where we have, so we're saying that the gradient of changing y of changing x of the tangent, when multiplied by the gradient of the normal, should give us -1. And we are having that the gradient of the tangent equals to 1. All right, so why don't we give this unknown, let's say y, -1 there. So for us to find the gradient of our norm, basically it's going to be what? Yeah. So the gradient of our normal is going to be -1. So the gradient of the tangent will be 1. Then the gradient of our normal here will actually be -1. And so now we have the gradient of the normal, and so we can find the equation of the normal to the curve. And so we know that for us to find the equation of the normal of the curve with the gradient, you're just going to pick the points and use the concept of changing y all over changing x to find the equation of that straight line there. And so basically it's going to be y minus -2 all over x minus 1, and we're going to equate it to the gradient, and that is going to actually be -1. And so we're going to cross multiply, and when we cross multiply, we're going to have y plus 2, that is negative times negative, giving us 2 there, equal to -1 into x minus 1. All right, -1 into x minus 1. And so the value of y, when you equate the value, when you expand this, we're going to have it as -x, right, plus 1. And so when you make y the subject of the formula, we'll find that y is equal to -x, all right, minus 1. All right, so -x minus 1. And that actually happens to be the equation of the normal to the curve at the point 1 and -2. Now, if you have any question, you're free to send me an email. I'm going to drop an email in the comment section, or you can drop a comment in the comment box, and I'll get back to you as soon as possible. Thank you, and have a good one.